when we watched the video, we should have learned that based on Dalton's law of partial pressure, each part of the pressure should add up to be the total pressure. So if I'm looking at this particular question, what is the atmospheric pressure if the partial pressures of nitrogen, oxygen, and argon are 604.5 millimeters of mercury, 162.8 millimeters of mercury, and 0.5 millimeters of mercury, respectively? Now, in order to calculate those, ladies and gentlemen, okay, in order to calculate those, ladies and gentlemen, we need to find the total pressure based on partial pressures. We have partial pressure of nitrogen, okay, partial pressure of oxygen, and the partial pressure of argon, right? So all I need to do is take those values and add them together. So if I look, the total pressure should be 604.5 millimeters of mercury plus 162.8 millimeters of mercury plus 0.5 millimeters of mercury. When I added all of those together, my total pressure came up to be 767.8 millimeters of mercury. Now, let me ask you this. Do I have the correct number of significant digits? Do I have the correct number of sig figs? How many people vote yes, Mr. Braun is correct on his sig figs there? How many people vote no, he is not correct on his sig figs there? Okay? I want you to keep your hands up if you voted no. You folks are the ones that are wrong. Because I have the correct amount of sig figs here, because we are adding. When we are adding, we look at places. And what I mean by that, here's a tenth, there's a tenth, there's a tenth. So I should round to the tenth. So does Mr. Braun have the correct amount of sig figs? Absolutely, he does. All right. So the answer here is the total pressure is 767.8 millimeters of mercury. Now you're going to see as we go on today, we're going to deal with different labels for pressures. You're going to see millimeters of mercury. You're going to see inches of mercury. You're going to see pascals. You're going to see kilopascals. You're going to see something called a torr. All right? How do we, in our system here in the United States, how do we measure pressure? Okay. We use inches of mercury. Okay. If I'm checking my tire pressure in my car, any idea? What is that? PSI, pounds per square inch. Okay, PSI. So we'll be dealing with some of those, and I'm going to have you copy a chart here coming up. All right, I'm going to have you copy a chart here coming up, but we're going to do another example first. Go ahead and copy this example down, and we'll work it. The question states, a 250 milliliter sample of oxygen is collected over water at 25 degrees Celsius in an atmospheric pressure of 101.325 kilopascals. What is the pressure in kilopascals of the dry gas alone? All right. So basically what's happening, it's something like similar to the video. We are collecting a gas based on water displacement. Okay? We're displacing the water, collecting a gas. So, my total pressure is going to be equal to the pressure of the oxygen plus the pressure of the water. The pressure of the oxygen plus the pressure of the water. Now, we know what the total pressure is because it's telling me right here, atmospheric pressure of that. Now, this is going to be very similar to how we calculate the pressure in the lab coming up tomorrow. It's going to be real similar. All right? So, my total pressure is 101.325, and we're dealing with now kilopascals. Now, what we'll find later, folks, and what you'll find later, being right now, is that in order to do this, I have to have a chart like this. And this chart, I understand it's a little bit blurry. This is all the clearer I could get it when I put it onto the smart board, the smart notebook. But as you can see, it is a table of vapor pressure at water. So, if I know what temperature the water is at, if I know, let's say it's room temperature, okay? Or in this case, the water was at what temperature? 25 degrees Celsius. Can I read this chart and find the partial pressure of water at 25 degrees Celsius? Sure I can, and that number is 3.2, and my label? Kilopascals. Now, will all of the charts I use be kilopascals? No. The one you're going to use in your lab is going to be millimeters of mercury. All right? But I know now that my value is 3.2 kilopascals. Can I solve now for the pressure of oxygen? Well, I hope. Can you take 101.325 and subtract 3.2 from it? When I do so, I get my PO is equal to 98.125. Now, based on my sig fig addition rules, that goes 3 places after the decimal. That goes 1 place after the decimal. So my sig fig should be 1 place after the decimal. So right here, so when I sig fig that, I'm going to get 98.1. My label is kilopascals. Not real tough, is it? Okay. But once again, in order to do this, we have to have that chart. Now my third example, I want you to copy something down before you get this example. I want you to copy this chart. This chart is going to save you from having to look up on the internet this stuff. So copy down this chart, and then we'll talk about it here in a second. Okay, as I told you, folks, you're going to need this chart to do some conversions. Okay, and the very first one is coming up with our next problem. Okay, because you can see there that it has a torr down at the bottom, right? So a torr is another abbreviation for a pressure. Now, when I come up with this question, go ahead and copy the question down. A 32 milliliter sample of hydrogen gas is collected by water displacement at 20 degrees Celsius and 750 torr of total pressure. What is the pressure of the dry gas alone? Once again, this is a Dalton partial pressure one. So my total pressure is going to be equal to the pressure of the hydrogen gas and the pressure of, and the pressure of the water. So the two partial pressures. Now, I know that this table here, where I've got to find my partial pressure, is in kilopascals, right? I was just given torrs. So I've got to do a conversion. So I come back and I look and I say 750 torrs. Here's my chart. 750 torr. I need to find kilopascals, but I only have one torr is equal to 133.322 pascals. Could I get that into kilopascals? How would I do that? How would I convert from pascals to kilopascals? Okay. I'm not going to say I would multiply by 1,000. Okay. I would divide, or I can simply jump my decimal point 3 places which way? To the left. 1, 2, 3. So, if I'm setting up a conversion box, I want to put 1 torr on the bottom, and on the top I want to put 0.13322 kilopascals. Obviously, my torr cancels, so I get my value here in kPa, kilopascals. When I did the math of that, I came up with a value of 99.9915 kilopascals. So that is my total pressure. I come back to this problem. So my total pressure is 99.9915 kPa is equal to my partial pressure of hydrogen. Now, I've got to go to my chart to get my partial pressure of water. I have 20 degrees Celsius. So when I switch back over to my chart, I find 20 degrees Celsius, and that is 2.3 kilopascals. I read my chart for 20 degrees Celsius. So When I bring it back to my problem, I have 2.3 kilopascal. When I do the math, can you do the math to solve for the pressure of the hydrogen gas? I hope so. Take 99.9915 and subtract 2.3. So I'm going to get 97.7915, right? But if I sig fig it, what do I need to do? 97.8 kilopascals. No, that's wrong. That should be 7, right? 98.7. I 3 minus the 9 is 6. Should be 97.7 once I look at it. Right? Is that what you were going to say? Okay. All right. Now,